Hello and welcome to the VEX Classroom. My name is Lauren Harder, and in this video we're going to talk about claw design. So some of the different aspects of claw design that we're going to cover is, first of all, what exactly is a claw? How is it used? And how can we not only see it not only on our robot that we have right here, but also just in many aspects of the world, how do we see claws being used? Not only what is a claw, but then also how does a claw work? Mechanically, how does it function? How does it open and close? And depending on the particular design, what certain aspects of the claw need to actually move in order to grab objects. And then not only how does a claw work, but what makes an effective claw? There are many different types of claw designs, and how do I know which one is best depending on the certain situation that I'm in? So let's start off with what exactly is a claw. So I have a bunch of different claws here on the table, and I'm going to show you some of their different designs as we continue on through the video. But just in general, a claw is one of the simplest types of grippers. And a gripper is used to pick up and transport objects. Now, these are also known as manipulators. So the task at hand for a claw is that I want to grab onto or hold some object, grab it, and then transport it. Now, some of these claws can be attached to certain arms, like you see on this example here. Some of them can just be attached to a simple drivetrain mechanism so that they can drag objects. It just depends, again, on the task at hand. Now, we do have some claws that you see here, but again, they are also used in many different aspects of the world. So as you can see, one example here, we have an example of a claw that's actually being used in industry on an assembly line. And you can see that the design of that claw is being used to grab objects that are more rectangular in shape. So again, just depending on the objects that we're actually manipulating, what does the claw design have to look like? So this one is just an example, again, being used in industry. We have another one here of being used on a rover in space. So this one can be used to pick up or deposit certain space samples. And another example that we have here is claws attached to the end of a submarine that can go down to the ocean floor or to coral reefs and actually pick up some different aspects there as well. So again, all of these different claw designs, depending on the environment, depending on the object that it's actually going to pick up, is going to distinguish the design of the claw. Now that we've covered exactly what is a claw, where can we see it, let's talk about how it actually works. So I have a few different examples here on the table. And the first one I'm going to show you is the Clawbot design. So here we have our Clawbot. You can see that I have two pieces here to the claw that are going to be used to open and close. Now, most claws operate with a type of motor or a power source. Some other different claws maybe use pneumatics. It's just depending, again, on your claw design and what it is that you're actually picking up and transporting. Now, this particular claw has the power source of the motor, and then we have a lot of different components going on inside, such as a shaft that then leads to a gear, and then because these two gears are meshed together, they actually open and close. Now, the other examples that I have here on the table as well are some different designs. Now, this one, again, is still being powered by a motor, and it is opening and closing, and you can see here that it's also using gears. But we have a couple different aspects to that as well. Not only is it just using gears, but we also have some rubber band components. And then this other design that we have has a bunch of different gears, but again, still using the motor as a power source. And you can see that that open and closes as well. So we'll talk about these designs in just a little bit when we get further into what makes an effective design depending on the object. But getting back to how this one actually works, talking about not only do we have motor as a power source here, but we also have it in some of our other designs. When we actually break this build apart, we can see that there's a lot of different components happening here. So we have the motor as the power source at the top, which then leads into the shaft. So I have a shaft that's attached to the motor, and that same shaft is actually also attached to those gears at the bottom there. And then the gears are meshed together, which allows them to move. When one gear moves, because they're meshed together, both of the gears move. Now, only one of these two shafts is actually being powered by the motor. And again, that's okay. I don't need both shafts actually being powered by the motor because the gears are connected down here, so only one of them actually needs to spin in order for the claw to open and close. Now, one thing about the gears is that these gears are actually the same size, which makes it a 1-to-1 gear ratio. And because of that, when the gears are meshed together, they actually spin in opposite directions. So as this one is spinning inward, this one's actually spinning down, and we get this sort of motion happening with the gears. Now, this is effective for our design because, again, we want them to spin in opposite directions, which allows that closing motion. So that's going to allow us to open and close and grab objects that I want to place inside the claw there. Now, that could be different depending on different designs. However, just talking about this particular design and how it works, we have the power source from the motor leading down to the shaft, attaching to the gear, and then because these two gears are meshed, that allows us to have that open and close design. Now, let's talk about what makes a claw effective or an effective design. So now we've covered what exactly is a claw, where have I seen it in some different aspects, how does a claw actually function. Now we're going to talk about what makes an effective claw. So again, this all depends on the object that I actually want to manipulate. So getting into some of the different designs that we have here on the table. This particular design here can be used for many different aspects. We can see that it does have points of grip right here on the side. So if I wanted to pick up an object and drag it, I also have an arm component so I could lift objects off of the ground. It just depends, again, on the object that you have in there. Some things to keep in mind as we are designing a claw for the object is what size is the object, what's the shape of the object, how high is the object off of the ground, and also what's the weight of the object. Does the claw need to be more strong, or can it be not as strong depending on the weight if I need to actually grip that object and even further lift it off the ground? So let's talk about some of these other claw designs that I actually have here on the table as well. The first one is going to be this one, which is actually from one of our IQ Hero bots called Stretch. So as you can see here, this is actually from this build. It's from the VIQ C game Ringmaster. And talking about its design, you can see there on the right-hand side, it's actually designed to pick up and transport multiple discs, or these rings. Now, the shape of the ring and how many of those rings I can actually pick up and move, again, influenced this design. So again, looking at that design there and then looking at the actual claw, you can see that here I have this power source and I'm opening and closing, but you can see that because of these rubber bands here that I have on the side, that's going to allow me to grip the ring as I collect it. And then because we have this additional height piece, that allows me to collect more than one ring at a time without them spilling over. So just looking at some of our other designs that we have, if I tried to collect a ring with this, I may not be as successful because number one, it's a little bit higher off the ground, so I may not be able to reach it. And number two, because there's not a lot of height here on this particular claw, I may only be able to pick up one ring at a time. So again, you can see depending on the object that I'm actually trying to pick up and transport is going to distinguish the design that I have for the particular claw, and that's what makes the claw effective. So again, thinking about what is the object or how many objects I actually need to pick up and transport. Now, another example that I have here is from the ArmBot. So this particular one that I have here is actually designed to pick things up going downwards. So if you can see the example there that I have on the left, that's from the ArmBot, and this is actually intended to be held upside down like this, and its objective is to actually close, hold objects in the claw, and then you can pick things up, move it around, and then open back up again to release them. So looking at not only the design, but also what is the object that we're picking up. So this can be used to pick up different size cubes, different shape of balls. That one looks actually more octagon in shape. So it just depends on the object, again, that we are actually picking up and transporting. So looking at this from the front view, again, we have the claw and it's designed to actually go top down. So just thinking again, if I'm trying to pick up, for example, different shapes of balls, one thing that you have to keep in mind there is that they roll a lot. So if I have a claw that's going sideways and grabbing something, I may not be as successful because if I'm going to actually reach that, it may push it away. So having a design that's actually top down, which allows me to grab certain objects in that manner, is actually more successful than if I were to accidentally push that ball and it roll a lot further than if I were to try to grab it originally. So again, all of these factors play into account of my particular claw design. So thinking about, again, what is the object? What is its shape? How heavy is it? Play into account of how I should actually design the claw for its particular purpose and function. So that's pretty much all that I have on claws. Again, recapping, what is a claw? How does a claw work mechanically? Again, getting into the motor, which is the power supply, getting into being then transported to the shaft, and then the gears and all of those working together to give us that open and close motion. And then what makes an effective claw? So again, analyzing the objects that we actually need to pick up and move, thinking about how those objects need to be transported, their size, also how it's going to be attached to the robot, is there going to be an arm involved, am I going to be dragging it, pushing it, and different things in that manner. So all of those different criteria, all of those variables play into account when you are designing your claw, and I hope that all of this was helpful, and I can't wait to see your different claw designs.